There are moments in human history that words cannot fully carry. Moments where the only honest response is silence and the only adequate language is the image itself. April 1st, 2026, at 6:35 in the evening Eastern Time was one of those moments. At Launch Complex 39B at Kennedy Space Center in Florida, the same pad that sent Apollo 10 toward the moon over 50 years ago, the most powerful rocket NASA has ever flown ignited its engines and began to move. 4 RS-25 engines and 2 solid rocket boosters producing 39.1 meganewtons of thrust at liftoff. Numbers that mean nothing until you watch the footage, until you see the solid rocket boosters light up in a blinding wall of white fire that turns the Florida evening into something that looks like a second sunrise. Until you watch the Space Launch System, taller than the Statue of Liberty, wider than a city bus, carrying 4 human beings inside a spacecraft named Integrity, lift off the pad with a slowness that makes the scale of it comprehensible. The ground shakes, the air shakes. The water in the deluge system surrounding the pad vaporizes into instant clouds of steam that billow outward like something alive. And then the rocket clears the tower and the engines really open up and the entire sky becomes light. The footage captured from the Filmar's cameras, the Flight Imaging Launch Monitoring Real-Time System cameras mounted directly on the SLS rocket itself, is unlike anything that has ever been recorded from a human spaceflight vehicle. These are not cameras positioned on the ground or on a chase aircraft. These cameras survived the most violent mechanical environment in human engineering. They rode the rocket. They felt the vibration of 39 meganewtons of thrust from 12 inches away. And what they recorded, the raw, unfiltered, physically immediate view of Earth falling away as the most powerful rocket in NASA's history burns its way through the atmosphere, is the kind of footage that reaches through a screen and grabs something inside you. The Florida coastline appears in the frame, curved slightly against the darkness of the upper atmosphere. The curvature of the Earth becomes visible, and the rocket just keeps climbing, the engines just keep burning, and the sky just keeps getting darker until it stops being sky at all. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency mission specialist Jeremy Hansen rode that rocket. 4 human beings, sealed inside Orion, pressed back into their seats by the force of acceleration, watching their planet recede through the spacecraft's windows as they became the first humans to leave low Earth orbit since the final Apollo mission in 1972. The mission lasted nearly 10 days. It traveled a maximum distance from Earth of 252,756 miles, the farthest any human being has ever been in the history of our species. And the photographs and footage it returned are, frame by frame, some of the most extraordinary visual records of human experience ever created. The image that may define Artemis II, the way Earthrise defined Apollo 8, was captured on April 2, 2026, the first full day of the mission, as the crew completed their translunar injection burn and began the long arc toward the moon. Through one of Orion's 4 windows, an astronaut pointed a camera at Earth. What the lens captured is almost too beautiful to process at first glance. Earth fills one portion of the frame, its blue and white surface catching the sunlight on the day side while the night side falls into deep shadow. But that is not the extraordinary part. At the bottom right of the image, zodiacal light, the faint glow of sunlight scattered by dust along the plane of the solar system, rarely photographed this clearly from space, streaks across the black. And in the upper right and lower left corners, 2 auroras, green curtains of charged particles interacting with the edge of Earth's magnetosphere, shimmer with a delicate, ghostly light that no photograph taken from the ground has ever captured with this clarity. This is what Earth looks like from beyond its own magnetic field, seen for the first time by human eyes in over 50 years. The footage from inside the Orion spacecraft adds a dimension that changes the emotional quality of the entire mission record. Watching Victor Glover, the first black astronaut to travel to the vicinity of the moon, float weightlessly to a window and press his hand against the glass while the lunar surface fills the frame outside is not a moment you watch neutrally. You feel it. Watching Christina Koch, the first woman to travel to lunar distance, look out through her window at a view that no woman in human history had ever seen before with her own eyes, watching Jeremy Hansen represent Canada in the farthest journey any Canadian has ever made, watching Reed Wiseman describe what he is seeing to mission control with a voice that keeps catching with something that is not quite emotion and not quite professionalism, but somewhere between the two. All of it accumulates into something that the word footage cannot quite contain. The Earth-set images from the far side of the moon are where the Artemis II visual record becomes genuinely historic. On April 6, 2026, at 5:41 in the afternoon, Central Time, the Artemis II crew photographed Earth setting over the curved limb of the moon's far side. In the frame, the moon's ancient surface fills the foreground. Oriental Basin, perched at the edge of the visible surface, Hertzsprung Basin showing its two subtle concentric rings, interrupted by the younger crater Vavilov, the lines of secondary crater chains formed by the ejecta from the impact that created Orientale. The geology of the Moon, undisturbed for billions of years, captured in extraordinary resolution. And above it, small against the black Earth and crescent phase, its day side showing swirling clouds over Australia and Oceania, its dark side in shadow. This is Earthset, Earth setting over the Moon. The photograph echoes the iconic Earthrise image from Apollo 8 in 1968 in its emotional power and its disorienting beauty, while being entirely its own thing, its own moment, its own crew, its own chapter in the story of human exploration. 2 days later, on April 7th, the Artemis II crew captured something that no crew of astronauts had ever photographed before at this scale or with this clarity. They photographed the Milky Way, from behind the Moon, 252,000 miles from Earth, free of every source of light pollution, in conditions of darkness that no human being experiences anywhere on Earth's surface. The crew pointed their cameras at the galaxy. The image shows the elegant spiral structure of the Milky Way in a way that ground-based astrophotography, even the best of it, from the darkest sites on Earth, cannot replicate. This is not a composite. This is not a long exposure image from a mountaintop observatory. This is a photograph taken by human hands through the window of a spacecraft at the farthest point from Earth any human has ever reached. The core of the galaxy glows in the center of the frame. The spiral arms sweep outward. And somewhere in that image, if you know where to look, is the pale blue dot where everyone who has ever lived was born. Then came the solar eclipse image, and this one stops people completely. On April 6, 2026, Orion's cameras photographed the Moon from a position where the Sun was directly behind it. The Moon, backlit by the Sun, it was eclipsing from the spacecraft's perspective, appears in the frame as a dark disk rimmed by the corona, the Sun's outer atmosphere, blazing in a halo of white and gold around the silhouette. Orion itself is visible in the foreground at the left of the frame, its solar arrays catching the light. Earth appears as a faint crescent at the left edge of the Moon's disk, and just below the Moon's bottom right edge, bright enough to be visible against the solar corona, is Saturn. Beside it, at the right edge of the image, Mars. In one photograph, the Orion spacecraft, the Moon in solar eclipse, Earth in crescent, Saturn, and Mars. Every object in that frame is a world. Humans are in that photograph, looking out at all of them simultaneously. It may be the most complex and astonishing single-space photograph ever taken. The final chapter of the visual record is the splashdown. April 10th, 2026, Pacific Ocean, off the coast of San Diego. The Orion spacecraft, named Integrity by its crew, before launch, descending through the atmosphere at re-entry speeds that generate temperatures approaching 5,000 degrees Fahrenheit on the heat shield. The footage of re-entry captured from the spacecraft itself shows the plasma that builds around the capsule during hypersonic atmospheric entry. The ablative heat shield doing its work, the air around the spacecraft ionized into a burning envelope of light. From the outside, filmed by aircraft positioned to track the descent, Integrity falls beneath 3 massive orange and white parachutes through the blue California sky and touches down on the Pacific surface in a spray of white water. The hatch is open. 4 astronauts emerge, and they are pulled out of the ocean by the U.S. Navy onto the deck of the USS San Diego, squinting in the sunlight of a California morning after 10 days of looking at Earth from farther away than any human being had ever been. The 8K footage from Artemis II is not simply a higher resolution version of what space photography has always looked like, it is a qualitative shift. At 8K resolution, the detail in the lunar surface images is sufficient to identify individual geological features. Crater chains, ejecta fields, lava plains, frozen in time billions of years ago. And at 8K, the texture of Earth's cloud cover becomes 3-dimensional, each cloud system a structure with depth and form rather than a flat white shape. At 8K, the stars in the deep space images are resolved with a clarity that makes them feel near rather than impossibly distant. And at 8K, the human face is visible through Orion's windows. The expressions of 4, people doing something no human being had done in half a century, are legible in a way that connects the viewer to the experience in a manner that compressed, lower-resolution footage simply cannot replicate. The visual record of Artemis II will be studied, exhibited, published, and replicated for generations. It will appear in textbooks. It will hang in galleries. It will be screened in planetariums and used in classrooms to show children what the universe looks like from the farthest edge of human reach. And among all of it, all the launch footage and the re-entry imagery and the mission control photographs and the orbital portraits and the geological surveys, the image that will last longest is probably the simplest one. An astronaut's hand pressed against a window, Earth in the glass, the Moon filling the frame outside. And between that hand and the surface of another world, 250,000 dollars. Miles of black space crossed by human beings for the first time in 54 years. This is what Artemis II looked like. Every frame of it earned. Every image worth every year that led to this moment. There is something specific about the way 8K footage changes the experience of watching a space mission that is difficult to articulate until you have actually experienced the difference. Lower resolution footage, even 4K, which was the standard for space documentation for years, creates a perceptual distance between the viewer and the subject. The compression artifacts, the loss of fine detail, the softness in moving objects, all signal to the brain that what it is watching is a recording of something that happened somewhere else. High enough resolution removes that distance. At 8K, the footage of the SLS rocket clearing the launch tower does not look like a recording. The texture of the flame is visible. The way the solid rocket booster exhaust is a different color and quality from the RS-25 engine exhaust. The water vapor clouds that erupt around the launch pad have individual droplets you can track in slow motion. The heat shimmer that distorts the air around the engine bells is visible as a physical phenomenon, not a blur. The effect is immersion rather than observation, the sense that you are not watching the launch from a safe distance, but standing at the edge of the exclusion zone with 8.8 million pounds of thrust igniting 300 meters away. The lunar surface images from Artemis II carry the same quality in a different emotional register. The moon, as seen by human eyes from Orion's windows, is not the flat gray disk visible from Earth's surface. It is a three-dimensional landscape of extraordinary complexity. Mountains casting long shadows in the oblique solar illumination of the lunar terminator. Ancient impact craters overlapping each other across billions of years of geological time. The dark, flat plains of the mare regions, contrasting with the bright, heavily cratered highlands in a pattern that is immediately recognizable as the face of the moon, but completely transformed by proximity and resolution. The 8K images from Artemis II show the lunar surface with a sharpness and detail that transforms it from an astronomical object into a landscape, a place where human beings will stand in 2027, and where the surface features visible in these Artemis II photographs will serve as navigation landmarks for the crews that follow. The 8K cinematic supercut assembled from all of this footage, the filmer's launch cameras, the exterior spacecraft cameras, the crew's personal photography, the splashdown imagery, is one of the most extraordinary visual documents in the history of human spaceflight. It tells the story of Artemis II not as a sequence of mission events, but as an experience. Watch it at full resolution. Watch it on the biggest screen you can find. Watch it in silence, the way the mission itself unfolded against the silence of space. And when the final frame lands, when integrity splashes into the Pacific and the crew emerges blinking into the California sunlight, you will understand, in a way that reading about it never delivers, why this mission was worth every year and every dollar and every hour of work that made it possible.